Hi and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 18, Examples Thin Pressure Vessels. The learning outcomes of this lecture is to learn the design of thin pressure vessel subjected to internal pressure. So in these lectures we learn two problems based on the thin cylindrical pressure vessel subjected to internal pressures. So let's consider first example, that is given a thin cylindrical pressure vessel of 1.2 meter diameter generates the steam at a pressure of 1.75 Newton per mm square. So here the thin cylindrical pressure vessel is given and diameter of a pressure vessel is given 1.2 meters and the pressure inside the pressure vessels is given, that is 1.75 Newton per mm square. And find the minimum hole thickness where if A is the longitudinal stress does not exceed 28 megapascal. So here we have to find the hole thickness. Condition is given if A longitudinal stress does not exceed 28 megapascal. So here longitudinal stress means sigma T2, that is 28 megapascals, and B the circumferential stress does not exceed 42 megapascal. So here circumferential stress is given and that value is 42 megapascals, or you know that it is nothing but the hood stress. So in these examples we have to find the minimum hole thickness by considering the longitudinal stress 28 megapascals, and second case by considering the circumferential stress or hood stress 42 megapascals. So first we collect the data given in the problems. So data given in these problems is B is the diameter of the pressure vessel, that is 1.2 meters. If we convert in mm, that is 1200 mm. P pressure intensity is given, that is 1.75 Newton per mm square. Sigma T2 is the longitudinal stress, that is 28 megapascals, or you can say 28 Newton per mm square. And sigma T1 is given, that is 42 megapascals, that is converted into Newton per mm square, that is 42 Newton per mm square. So here we have a value of sigma T1 and sigma T2, and pressure intensity P is 1.75. We have to calculate the thickness by two cases, case 1, case A and case B. So consider case A, that is when the longitudinal stress sigma T2 does not exceed 28 megapascals. So here we have to consider the longitudinal stress sigma T2. So sigma, we know the equations of sigma T2, that is the longitudinal stress, that is P into D divided by 4T. Or what is our M? Our M is to find the thickness of cylindrical cell when the longitudinal stress is 28 megapascals. So in this case, if we consider the equations of sigma T2 is equal to P D by 4T, so we can convert in terms in T is equal to P into D divided by 4 into sigma T2. So in this equations of thickness, here P is the 1.75 pressure intensity, D is the 1200 mm diameter of pressure vessels, and sigma T2 is the longitudinal stress, that is 28 Newton per mm square. So by placing this all value, we can get the value of thickness according to the 28 megapascals longitudinal stress, and we get the answer 18.75, says the 20 mm. So in first case, according to the longitudinal stress 28 megapascals, the thickness of pressure vessel is 20 mm. Now the case 2 is the case B is when the circumferential stress sigma T1 does not exceed 42 megapascal. Here we have to use the equation of sigma T1, and we know the equations of sigma T1, that is PD divided by 2T. So if we simplify that, T is equal to PD divided by 2 into sigma T1. So in this case, P is 1.75, D is 1200, and sigma T1, instead of here we have to use the circumferential stress. So sigma T1 is equal to 42 megapascal. So if we place all this value, we get the thickness of this pressure vessel according to the circumferential stress 42 megapascal, and that is equal to 25 mm. So in first problems we calculate the thickness of pressure vessels according to longitudinal stress as well as the circumferential stress. Now consider the second examples that is given. A thin cylindrical pressure vessel of 500 mm diameter is subjected to an internal pressure of 2 Newton per mm square. Here also thin cylindrical pressure vessel is given and diameter of pressure vessel is given 500 mm and it is subjected to internal pressure of 2 Newton per mm square. So P is 2 Newton per mm square. If the thickness of vessel is 20 mm, here the thickness of pressure vessel is given, so it is T is equal to 20 mm. We have to find the hoop stress, longitudinal stress and the maximum shear stress. So in this case we have to find hoop stress, that is sigma T1, longitudinal stress, that is sigma T2, and also we have to find the maximum shear stress, that is tau max. So in previous examples, longitudinal stress and hoop stress is given, and according to thickness is calculated, we have to calculate it. And in these examples, the thickness of pressure vessel is given, and we have to calculate the stress produced according to this pressure vessel. Now first we consider the hoop stress. Sorry. So given data is D is equal to 500 mm, P is 2 Newton per mm square and T is 20 mm. Now first consider the hoop stress. As we know, the hoop stress is the T sigma T1, and sigma T1 is equal to P into D divided by 2T. So sigma T1 we have to calculate, and for that we have to place the value of P, D and T. And all this value is given in problem. P is considered as 2 Newton per mm square, D is 500 mm, and T is the thickness of pressure vessel, that is 20 mm. So if we place all this value, we get the sigma T1 is equal to 25 Newton per mm square. Now second we have to calculate the longitudinal stress, that is sigma T2. So longitudinal stress sigma T2, we know that is the PD divided by 4T, and we have all this value P, D and T. So by placing this all value, we get sigma T2, that is the longitudinal stress, that is equal to 12.5 Newton per mm square. And from equations we can say that the hoop stress is the twice of longitudinal stress, and we can see in our answer that is hoop stress is twice of longitudinal stress. Now next is we have to find the maximum shear stress. So as we know, the maximum shear stress is the algebraic difference of maximum and minimum principal stress. So now in this case, sigma T1, that is the hoop stress, is the maximum principal stress, and sigma T2, that is the longitudinal stress, that is the minimum principal stress. So as we know that from hoop stress and longitudinal stress, hoop stress is greater than longitudinal stress. So we have to consider the maximum principal stress is the hoop stress, and minimum principal stress is longitudinal stress to calculate the maximum shear stress. Now according to maximum shear stress theory, we know the maximum shear stress theory, tau max is equal to algebraic difference of this maximum principal stress and minimum principal stress, and half of this difference. So tau max is equal to sigma T1 minus sigma T2 divided by 2. So here sigma T1, that is the maximum principal stress, and sigma T2, that is the minimum principal stress, and we calculate this both value in previous slide. So we can place this both value to calculate the tau max. So by placing the value of sigma T1 that is 25 Newton per mm square and sigma T2 that is 12.5 Newton per mm square divided by 2, we get the tau max is equal to 6.25 Newton per mm square. So we get the maximum shear stress according to the given configurations, and that is equal to the 6.25 Newton per mm square. That is our third answer. So in these lectures we learn the design problems based on the cylindrical thin pressure vessel subjected to internal pressure. So you can use the roof stress and longitudinal stress whenever you have to design the pressure vessel. Thank you.